Hello everyone, I am Minendra Surve. Completed my BE from Mechanical Engineering. I have completed my Masters in Mechanical CAD/CAM and right now pursuing PhD in Mechanical Engineering. So today we are going to discuss a very interesting subject, that is optimization technique, which is newly introduced subject for University of Mumbai in the last year, from last year. So this subject is a very vast subject, but the structure, if you look out the syllabus copy, I have a syllabus copy with me. The course name is optimization technique. The course code is given as MEDLO 5011. So what it stands for? ME is mechanical engineering, DLO, that is nothing but department level optional course, and the code name is 5011. Okay, and the credit assigned for this subject is 3 credits. So if you look out the objectives of this subject, the various objectives are listed, and what are the outcomes or learner will able to enlist, or these are the outcomes according to the 6 units. So I am not going to discuss the objectives and outcomes of that syllabus or content. We are going to discuss step-wise or one-by-one unit, and this is our lecture series entirely for optimization techniques based on University of Mumbai syllabus. So we'll start our lecture series, and this is our first lecture. So don't forget to subscribe this channel, and if you like the lecture series from the various subjects, thermodynamics lecture series is previously available, heat transfer, fluid mechanics, dynamics of machinery. So this kind of lecture series is available according to the GATE IS orientation. But the content we are going to discuss for this lecture series is totally based on University of Mumbai syllabus. So we'll discuss what do we mean by optimization first. So I have listed one basic definition for optimization. If you look out here, I have listed optimization is method of obtaining the best result. This is nothing but method of obtaining the best result under given circumstances. So that is the only one basic definition. But if you look out, various authors, various researchers has defined optimization on their different manner. So I have found out 8 or 9 definitions for optimization. Though the subject is optimization technique, but you have to understood what do you mean by optimization. It is the finding out the best result under given circumstances. For these definition, if I discuss one simple example, if I want to travel from IIT Mumbai to IIT Kanpur, the gate of IIT Mumbai to the gate of IIT Kanpur, which path I should follow? The optimization track will be gives a best result from the Google. Oh, or various paths are there for traveling from IIT Mumbai to IIT Kanpur. So this is a basic simple example how we can find various paths are available. But after Google search, you can find the best possible solution for this best possible path, or you can say with acceptance or with the existing solutions, how I can travel. It will give you a best result from two-wheeler, from four-wheeler, from own car, how much is the distance. So these all the tracking devices are available for Google itself. So Google will give you the optimized path. So this is nothing but choosing a best alternative results among the set of various alternatives that we can define will be the optimization. This is the in general definition for optimization. But as per the engineer's perspective, as per the various researchers' perspective, as per the mathematicians, how we can define optimization, that is the another way. So I have one more definition for optimization. I have listed optimization can be defined as the process of finding the condition. Process of finding the condition that give me the maximum or minimum value of a function. What? The process of finding the maximization or minimization value for the given function. This definition very as much suits to the mathematicians. The function is given to you, and according to that function, the process of finding the best, finding the condition that gives the maximum or minimum value of the respective function. So suppose f of x is function is given to you in terms of x cube plus 3x square. Likewise, the function is given to you, and and what is your aim, find out the root of the equations or find out the optimal solution for the given assigned function. Then you can find the best what is the best condition that will give the maximum or minimum value of the function, and definitely defines the optimization. Again, if I look out, the term optimize is to make a perfect. What optimizations simply suggests us to make a perfect, that is nothing but optimization. Now it is, if I want to define some another, so it is defined as choosing the best element from some set of available alternatives. How I can define or how I can elaborate this example, how I can elaborate this definition? It is defined as choosing the best element from the set of available alternatives. Suppose a salesperson has to travel in Mumbai to sell his components or some sales purpose. So if he has to travel from across all over the Mumbai, so how he can define his path from starting position, from which point I can start my my traveling destiny, and which will be my last point. Salesperson. So which route should he can follow so that he can save his time, as well as he can sell the lot of quantities also. So within the optimum time, how he can maximize his sale, that is the best thing. You can understand the definition, choosing the best element from some set of available alternatives. So he has a definite a lot of paths, but which path should he follow? Like the previous example I have discussed with you. So if I want to travel from IIT Bombay to IIT Delhi or IIT Kanpur, which is the best optimal path so that I can reach with the safety and with the minimum time and with a less effort? That will define us optimization. So again, some researchers have defined optimization by various manner. One of the researchers has defined an art. Okay, I will write here an art. What he defined: art, process, an art, process, or decision. Look at the most important word: art, process, and decision, or a decision. An art, process, or a methodology, not a decision actually. Art, process, or something, methodology. Art, process, or methodology. The three important words to define optimization: an art, process, or methodology of making something, of making something. Now what we have to make? Look at it, a decision. A decision, whether you have to make a very good decision, or either you have to make a one system, or decision, system, or a design. It is an art, process, or methodology by making a decision, system, or a design as a perfect, as a functional, as effective as possible. You have to make this is a perfect, as effective, as a functional as possible. So this is the definition of by the designer who has to think, who has to design a system as a cost effective, as a effortless, or as a functional, as effective. That kind of definition is also there, how to define optimization. Or it is the process of finding the best way of using the existing resources. Whatever the resources are available to you, you have to use that resources and found the process that will define an optimization, while taking into account of all the factors that influence the decision. Whatever is the existing resources that you have, and you have to account all the factors while using that resources, and you have to think whether these factors or these resources will influence the decision, will affect my decision. So this entire process is nothing but optimization. Now This is all whatever the I have defined optimization in various manners, 6 or 7 definitions. But what do you think as an engineer? What I can think as an engineer, what is an optimization? If I am engineer, I want to think like what I can define my optimization will be look like, or how I can define my optimization. So suppose in engineering design activities, suppose in engineering all design activities are there. If I look out at design, construction and maintenance engineers have to take many technological as well as managerial decisions as at several stages. As an engineer, suppose you are thinking like a design engineer, construction engineer or maintenance engineer, you have to take a decisions at several stages. So the main and important goal of such a decision, the main and important goal of such a design or decision, main goal of these activities, such a decision is either maximize the desired benefit. As an engineer, what I look out, maximize the how I can maximize my benefits, how I can maximize my benefits with consideration of decision. I have to make one decision whether if I taken that decision affect on my maximization productivity, efficiency, that I have to think before taking a decision. So optimization tells us a very interesting thing. You have to take that such a kind of decision whether this will influence benefit or not. Okay, or I'll talk about maximization the benefit, but simultaneously minimize the effort required. As a designer or a design engineer or any engineer, how I can think like a optimization will look like to maximize the benefit or to minimize the effort required. Suppose this way I have discussed with some kind of as a perspective from an engineer's point of view. If a mechanical engineer design mechanical components, what mechanical engineers do, they will design mechanical components, but according to them, what is the optimization process or what is the optimization? The as I want to design this mechanical component, how I look like, how I take a decision. There is a mechanical component when I going to manufacture with a minimum cost, but life will be a maximized. So definitely there are this process follows two things, two functions, function having either maximization or minimization value that mathematicians thinks, but the design engineers also thinks like that. How I to maximize the profit, how I to maximize the benefit, simultaneously I want to think on how I become minimize the cost, minimize the functions, minimize the effort required, or maximize the function, minimize the cost, minimize the efforts required. So this is the nothing but to design any component. Okay, if you look out the civil engineer's perspective, how we can think maximize or minimize, two functions are available. He has to make a dams, he has to make a various structures, buildings, or you can say any structure, buildings or bridges. That will be a civil engineer will think like how he can define in the way of maximization and minimization. What he can think, what will be the maximize in the civil engineer's perspective. So if you think to I want to design a dam or I want to design develop bridges, so overall cost of the system I am going to thinking this cost is going to be minimized. Overall cost I am going to minimize, but what I should maximize, the strength or the safety. The civil engineer's perspective, safety is the best important thing. Just like mechanical component, the life of the component is a major thing. I will maximize the life of the component. Any component, how we can last long or maximize, that I am going to think. But for minimization, as civil engineer, I will look like a cost will be a minimization criteria, but maximization will be a safety. Safety is the maximization function and minimization function is cost. Just like if you think about aeronautical engineers, same again. What aeronautical engineers look like, the fuse cell is nothing but the outer part of the component, or fuselage we call it as outer body of the aeronautical systems, that is going to be designed with a minimum weight. The function is he can reduce the weight of the system, minimization of weight, and maximization is the safety. Again, maximization is the functions requirement, maximization is the efforts required, maximization is the benefit, and all the things that cost weight, that will be going to reduce or minimize. So I have defined you the optimization in the various ways. I have defined your optimization in the various ways, and this is our first introductory lecture. Basically, you have easily understood what is the optimization, and the various techniques are available to do the optimization. That is the content, that is the part of the syllabus, and in this lecture series we are going to discuss what are the various techniques, what are the various methods, so engineers can apply these techniques or methods for the optimization purpose. So this is sufficient for today's first lecture introductory. Hope do you understood all the definitions of optimizations, and I think why we need the optimization is also you have understood. I will give you some basic example. If the classroom is designed like according to a timetable schedule. Simple example, the timetable schedule is prepared for first lecture, second lecture, third lecture, fourth lecture. Likewise, to schedule or to plan a very systematical manner without affecting the classroom dignity or without wasting any slot or time. So if the slot is missing, if a second slot is missing and the student has to wait for 1 hour, so this is not your ideal timetable, because you have to wait for 1 hour and this is not ideal time. Okay, after that 1 hour your classroom is your third lecture, fourth lecture is continued, but this is not an ideal timetable or this is not an ideal schedule. So we can say that this is not optimized timetable. What to do if it is optimized? You have to arrange some systematic manner so that without affecting the dignity or without affecting the entire decorum of the classroom, lecture 1, 2, 3, 4 in systematic manner without affecting the time. Okay, and maximization the efforts, maximization the productivity of the classroom, or understanding the concept, and minimizing the thing that is not going to be ideal, that you have to reduce from the timetable. So if I have put a lab lecture, if I have put a library lecture in between the first 4 lectures, and you have to make sure that you have to attend the lecture for lecture number 3rd and 4th after wasting the time for the second lecture, that is not ideal case. If what do you mean by optimization? The systematic manner, and maximize the function utility and minimize the other things, minimize the, as a standard I will tell you various factors are there, cost effective factors. So if time effective factors, minimize the time required for the cases like that where wherever you think on that, I want to think on the time. So this is the process of optimization. I definitely have understood all the definitions of optimizations. I have given a lot of examples, just like traveling from one place to another place. You can define optimum path, how I can travel, or if I have given a mechanical component example, how you can think what is optimization. If this is a mechanical component, I have to reduce the whatever is the manufacturing cost required, but ultimately I have to think to maximize this productivity, maximize the tool life, maximize the functions required. As well as I have given you civil engineering example, aeronautical examples, and as an engineer you have to think like way. So thank you very much.